Hello, my name is Dr. Miller. I teach Advanced Science Research, aka ASR. This is a 3-year program where students will, they get to choose to study whatever it is they find interesting. And I make it a requirement that they have to find it interesting because otherwise they won't put full effort into it. So this is a 3-year program, as I said, and students are going to learn basic techniques of research and apply it to whatever it is they want to research. There are a few goals for this class. One is that I can train my students to act and operate as professional scientists. Two, for our students to do well in local science competitions, which lead to national competitions. And the final and lofty goal is for our students to get their scientific work published in professional scientific papers, which might not sound good to the uninitiated, but it'll open many doors. This is an achievement not done until usually people are a few years into grad school. And I already have about a handful of students who have already accomplished this. So the main learning objectives is to be able to do what a scientist does. So think like a scientist, to understand how to use their techniques and to implement them towards whatever it is they find interesting. So this would break down into basic philosophy of science, what is science, all the different components, how to navigate scientific literature, what is it, why do we put so much weight and validity in scientific literature, what are some of the potholes of that system. Experimental design, all my students design experiments, little ones in the school that they test out their techniques on before they test it on the big projects. And scientific communication, once we bring an experiment to completion, the next goal would be to write up the results in a professional manner so you can communicate it both through a scientific paper, through a scientific presentation, or poster conference. So my students are studying because everyone gets to choose what they want to do. Their different learning objectives are all over the board. So some of the skills that I like my students to have are coding and statistics. So there's a few websites that I go to for coding. We used to use Replit, but the school's banned it, so we can't use that anymore for learning how to code, but there's a lot of nice resources. Typically the Python website have a lot of these. For students working on artificial intelligence, which might become a mainstream component of science in the future, we use the TensorFlow tutorials, which I believe come out of Google. And then other than that, some students are working on DNA, some students are working on psychology, and really we just find it as an as-needed basis from legitimate sources, and I don't really have a go-to for all of those. I was planning on making an ASR website though, so I'll keep you posted if that happens. So the biggest one is scientific curiosity. You have to find something interesting, something you're just dying to know about. After that, a lot of it is hard work, persistence, because we are dealing with real world goals here. It's very hard. Even this project that sounds simple, it can be very hard to kind of do it well and make sure that their conclusions are strong. So after curiosity, hard work, strong work ethic is the next one. And then of course being creative, learning quickly. All these can be overcome with hard work, but these are other kind of secondary attributes. Well, I try to provide a little bit of everything. If we could, I don't know if we could pan around the classroom with the camera. So if you look in the back here, we have a kind of experiment that's currently being developed. So here I provided basics, just a little bit of PVC pipe and the grow lights, and we have a 3D printer to help put our structure together. We have a microwave fuel cell, so things like electronic components, if we need to build a circuit to measure something. So again, because there's no finite goal that everybody's working towards, everyone's doing different things. I do my best. I have a background in experimental physics, so I'm pretty good at putting together detectors and circuits when needed, using either Arduino or Raspberry Pi, so we can have little kind of machines that do a lot of our data recording for us at a level that you couldn't do otherwise. But in general, anything you guys need, I'll do my best to get, as long as it's not prohibitively expensive. So this class is unique in that we have basically progress reports. So essentially every week we set goals, about 5 goals, for how to push your project forward. And how you are assessed are how well you meet those goals. Of course, some goals are understandably difficult and pretty fair. You can ask any of my former students. If a goal was much more difficult than it seemed on paper, I'm pretty fair about not taking off points for that sort of thing. Basics, showing up to class on time and getting to work. Let's see, what else do we have? So goal obtainment. Also, there's kind of like a category for what I call progress, where here students realize that the goals that we had set, there's another goal that we didn't write down that took priority over those, and they make that executive decision, of course touching base with me, so I get points for that, because really we're trying to get a real world project to be completed, and often the goals that we need to do there are changing. So I also award points for basically being creative and thinking on the spot in order to kind of make your project happen. It's fun. Often in class we got kind of tied up just going over something that we just find extremely interesting. Let's see, we've done everything from Sundays we're just calling, so one student wanted to do a psychology experiment on an octopus. So we couldn't afford to keep an octopus here, so we had to find people with octopus. We tried aquariums, so they would let us experiment on them initially. We found a private owner in Long Island who is an octopus crazy person who has an Instagram show. So we went on Instagram and we investigated the guy. He had a background in marine biology. We called him up, we talked to him, he invited us over to he had a chiropractor business with like 5 or 6 tanks of octopus in there, and we were able to go there and do the experiment. And so it was fun just looking around for that. The other day we were looking for chicken blood to see if we could cultivate bone cells in a petri dish. So we had fun just calling random slaughterhouses to see if they would give us blood. Apparently it's illegal in New York State, so we couldn't do it. So you never know what you're going to be doing in this class. I guarantee you it will be hard, and I'll guarantee you it will be fun. Too many to list here. In the back of the room right now, there's these 2 soda bottles there. So it's called a microbial fuel cell. It doesn't look very fancy because we did a very kludgy job of putting it together. This thing has been producing voltage. So it produces voltage using bacteria. And it's been turned on since last summer. It's still producing voltage. Currently, the voltage is very weak, unfortunately. It's about 0.2 volts, but currently we stumbled across a circuit that's going to enable us to store that and amplify it up to 100 volts so we can get useful energy. And the goal here would be to use one of these, go to like a wastewater treatment plant, put a bunch of these in there and get usable energy out of it. Here we're studying, so we're growing rice here, and the goal here is to basically infect the rice with a type of bacteria that will protect it from harmful bacteria. Alright, so that would be another project that's very interesting, very useful because rice is an important staple crop for the planet. Let's see, over here, here's the circuit that's going to amplify our microbial fuel cell. And that's just a few of the things. So this chamber eventually will be used to hopefully you take apart polyethylene or the majority plastic pollution on the planet using UV light in a vacuum. So we're trying to solve a lot of real world problems. I dare to say, this might sound not genuine, but it actually is. I think every project that happens here is actually really interesting. I really enjoy helping everybody with this, whether it's curing E. coli using hyperbaric treatment. We did stellar velocity analysis and hope finding signatures of dark matter. We didn't find anything, but it was fun. And really, it's just the craziest job I've ever had. Literally anything can happen here. I'll have to put a list of all the projects on our website and get that website to you soon so you can see all the kind of crazy stuff that happens here. But literally, sky's the limit. I've covered a lot, but if you love science and you have ever considered, or even if you've never considered science and you would like to you would like to try, this class is for you. As long as you're willing to work hard, and as long as you're willing to do something that's really, it's not going to be like your other classes. This is not linear at all. Okay, there's no test or anything like that, but we have to make real world goals occur, and that is a lot harder. So if you like a challenge and you love science, definitely consider this.